Hi, my name is Ron Lohman. I'm here with my colleague Dana, and today we're going to talk about one of the more exciting parts of AI SoCs, and it's really the type of security that's being implemented. So, Dana, what kind of trends are you seeing with respect to security implementations on AI chips?
Well, what I see is that security is becoming more and more critical. AI is being applied across so many applications. And so models need to be protected because they take a long time to be produced, investment from the companies to produce. So they need to be protected during use and updates. Training data, user data needs to be protected from the privacy perspective, but also there are laws and regulations that come up. As well as the neural network engine itself, the inputs and outputs of the engines and the results need to be protected.
So, is there a big difference between protecting the training function versus inference with respect to security, or the implementations similar?
Well, so if I look at the threat profile for artificial intelligence applications, there are many attack profiles, right? So you can attack at the training stage, you can attack or manipulate the data sets, the training data, and that can influence in a negative way the model. You can also steal the data. When we move to the inference stage, attacks or threats can be around the inputs and the outputs of the engine, right? And then the engine can take the wrong decisions. And the neural network engine can be manipulated and can misbehave.
Are there different regulations on the training aspect versus inference, or with respect to AI across the board, or is it just related to the use case and the threat profiles?
In addition to that, the biometrics, you can have medical records, you can have video information from within your house. So a lot of personal information that is critical and it needs to be protected. As I mentioned earlier, if they don't follow up with the laws and regulations, then they have to pay steep fines.
What types of security solutions are out there to handle all these?
Yeah, so if we think about the training data, protecting it from misuse or for tampering, solutions like signature as well as authentication before data is used, preventing data being stolen. We've talked about private information important for the users. That can be addressed via encryption. When we move to the inference stage, protecting the changing the model or manipulation of models, that can be also addressed by authentication and encryption.
This is public-private key exchanges, correct?
And another example is the neural network engine itself. So security solutions for those kind of engines approach and include secure boot, secure debug, as well as secure communication of that engine. But in addition to that, there are other security fundamentals. So key management is a crucial component for a security solution, whether it's AI or other system, because keys in security protocols are very sensitive information, and if you compromise a key, you basically compromise the entire security. So key management is important to be done in a hardware or secure enclave and distributed securely as well. Secure updates are also critical. We live in a world where the threat landscape continues to expand. And so the solutions need to be agile to adapt to future threats. So it's important to have the appropriate mechanisms in a solution to be able to update software or fix bugs remotely after the systems have been deployed in the field.
So when you talk about agile, you're meaning new threat profiles, new viruses that are out there, new ways to attack systems, correct?
Exactly, and there are some ways to mitigate in the SoC itself, where you don't need to respin the SoC, you just update securely the software that runs on that SoC. The threat profile that we've talked about earlier, the solutions really need to be tuned specifically, and that may mean you have more hardware real estate or more or less software, or vice versa. So it's a combination of hardware, software, and security level that needs to be be considered, and it has to be tuned for a targeted application. So starting with hardware, a hardware root of trust where you derive your keys and your important functions, we talked about secure boot, is more secure for sure.
So the threat profiles that you have helped customers with aren't just through the silicon design, but even after it and the software they implement on those designs?
Exactly. We want to make sure that we put the right foundation in the silicon to allow our customers and our customers' customers to upgrade software, to deploy services and control the devices throughout their life cycle in a secure manner.
Okay. And so how is Synopsys really addressing this with Synopsys solutions?
From hardware like secure enclaves with hardware root of trust, we have our T-Root product family. These types of products can support out-of-the-box functions like secure boot, secure update, key management, which I mentioned earlier, how critical they are. In addition to that, we have security protocol accelerators that can be used to encrypt and authenticate models as they are being updated, for example, as well as can be used for secure communication. Another important aspect, which I forgot to mention earlier, in AI, we're dealing with large data sets, and they are important in value, right? And so the memories need to be protected as well that deal with that data. So inline memory encryption is another technology that is critical, and we also have high performance, low latency solutions that can protect data in memories as well. So we have a lot of solutions. They can be tuned for applications, and they work very well hand in hand.
So addressing lots of different customers, we've seen lots of different threat profiles, lots of different security implementations. Is there anything else you want to add from Synopsys' perspective of solutions we provide?
Well, our approach is to stay on top with the latest standards, regulations, and be able to provide the appropriate solutions for customers that can be differentiated in the market. And we will continue to be driven by this goal.
Well, I want to thank you for sharing your expertise today.
You're welcome.
It's obviously a very exciting time with implementing security in AI chips specifically. And if you want to hear more, please visit synopsys.com.